All right, let's try a little bit more practice with graphing an inequality. So let's look at this inequality here, and we'll notice that this symbol right here is greater than or equal to. But the first thing we're really going to do is just think about this as an equation that we are going to graph in intercept form. So we're going to think about the y-intercept value first, which is positive 4, and then the slope value second, which is negative 2/3. So negative 2/3 means from our y-intercept, we're going to rise negative 2, we're going to go down 2, and then we're going to run positive 3. So we're going to run to the right 3. So down 2, right 3, down 2, right 3, down 2, right 3. All right, and we can reverse that pattern back at the y-intercept if you want to go up to left 3. We get on that same line, up to left 3. We get on that same pattern, so we get a few points. And once again, we're going to now draw the line in, just like we're graphing a line in slope-intercept form. But this time, we know that all of the points on the line are solutions. So anything on the line, and some of these will be fractional values, anything that we plug in there, an xy ordered pair, will make this inequality true. But not only that, anything that is greater than or equal to the line will also be true. So we can shade above the line, and any points, any ordered pairs that are above the line, all the infinite ordered pairs that go off into infinity up here, any of these xy values we could put in for x and y in the inequality, and it would make the inequality true. So that is how we would graph that inequality and show the solution set. All right, now look at the one that is below and notice that there's just a slight difference on this one. It almost looks like the same thing, but notice the symbol right here is simply just a greater than. Not a greater than or equal to, but just a greater than symbol. Now, that really just has a minor change on how the solution set is going to look for this. We're still going to graph that y-intercept of 4. All right, and we're still going to graph that slope of negative 2/3, so going down 2, and then right 3, down 2, right 3, down 2, right 3. Reverse the pattern if you want, back at the y-intercept, up 2, left 3, up 2, left 3, gets on the same line. Okay. Now remember our one variable inequalities when we talked about how if it was just a greater than or a less than sign that we would have an open circle rather than a closed circle. So this was for like greater, less than or greater than signs, and this was for less than or equal to, greater than or equal to. Well, with two variable inequalities, we kind of do the same idea. Instead of a solid line like we had up above, we kind of do that open circle idea by making a dashed line instead of a solid line. Okay, so this means all of the ordered pair points that are on this dashed line are not solutions. All right, because those are going to be equal to the line, and what we want them in this case is to be greater than the line. So we still shade this whole area on the greater than side, so in other words above the line, so any of these points would make the inequality true, but the points on the line will not make the inequality true, right? Because they have to be greater than, not greater than or equal to. So that's the difference between these two. Almost the same thing, just that this one, the points on the line are solutions to the inequality. They will work. Versus this one, the points that are on the line are not solutions. But in both cases, anything above the line will be solutions. Any points, any xy pairs above the line will be solutions.